Welcome back to Hardware Unboxed. Today we are taking our first look at AMD's new Fidelity FX Super Resolution 2.0 technology, their second attempt at offering a broad game upscaling technology to compete with Nvidia's DLSS. Since the release of DLSS 2.0 more than 2 years ago, it's steadily become a key selling point for Nvidia's GPUs. Lots of gamers have been buying GeForce GPUs specifically for this feature, so AMD has needed something to counter the technology for their Radeon customers. AMD's first attempt at curtailing DLSS was FSR 1.0, which was released a little under a year ago. While we found that FSR 1.0 was effective in some situations, particularly at 4K using the ultra quality mode, it ultimately wasn't as good as DLSS overall. The image quality at 1080p was unimpressive, and the performance mode looked quite a bit worse than DLSS. AMD using spatial upscaling versus DLSS using temporal upscaling proved to be a significant obstacle for FSR 1.0. However, the broad compatibility for FSR and its quick adoption across a large number of games were positives. FSR 2.0 is a significant upgrade to AMD's upscaling technology, moving from a spatial technique to temporal. If you want to learn more about how FSR 2.0 works, we covered a lot of information when it was first announced, so it's worth revisiting those videos. But basically, the shift to temporal scaling allows FSR 2.0 to combine current frame information with data from previous frames and motion vectors to reconstruct the final image, utilizing a lot more data than is possible with spatial scaling. By having access to all this data, it's possible for FSR 2.0 to produce better than native results, like Nvidia also claims for DLSS. Where FSR 2.0 and DLSS differ is in how they approach the puzzle of reconstruction and choosing which bits of data to use. DLSS takes a closed source, AI-based approach, which requires specific instructions exclusive to Nvidia's Tensor Core hardware. FSR 2.0 doesn't use AI at all, instead using a hand-tuned algorithm that's open source and supports a wide range of hardware just like FSR 1.0. Tensor cores or other specialized AI processing blocks are not required. We were able to get FSR 2.0 working on 5-year-old hardware without any issue, more on that later. Today we're getting the first opportunity to evaluate FSR 2.0 in Deathloop, a game which thankfully also supports FSR 1.0 and DLSS, so we can make a nice comparison between today's main upscaling technologies from the two GPU vendors. Now, I wouldn't call this an FSR 2.0 review necessarily because we are just looking at a sample of one game. We'll need more than that to make a definitive call on FSR 2.0 versus DLSS, but at the very least we'll be getting a good preview of what FSR 2.0 can do. And Deathloop is a particularly good example to use because DLSS is very effective in this title. It's one of the best examples of DLSS producing a better than native image, while FSR 1.0 looks less than amazing here, so FSR 2.0 will have to perform well to impress. The FSR 2.0 patch for Deathloop should be going live today as well, so if you own the game, I'd recommend checking it out yourself. There's really no barrier to entry here, but to save you some time, let's get into our examples, starting with a look at 4K. FSR 2.0, like DLSS, has 3 quality modes available in Deathloop: Quality, Balanced, and Performance, which correspond to a 1.5, 1.7, and 2.0 times scale factor respectively, roughly in line with what Nvidia offers. This means that at 4K, using FSR 2.0 quality, means we're upscaling 1440p to 4K, while using the Performance mode gives us a 1080p to 4K upscale. When looking at static imagery, there's not a big difference between the 3 FSR 2.0 modes. This is because FSR 2.0 is accumulating data across multiple frames, and if those frames don't change very much, it can build up enough information over time to create a near-perfect reconstructed image regardless of the actual render resolution. The only noticeable change here between the quality and performance modes are very small reductions to fine detail quality. The overall presentation is mostly the same, just like we see with DLSS moving from quality to performance modes. Of course, the big question is how FSR 2.0 compares to other technologies, so let's take a look at the highest quality offerings. The first thing I noticed is that FSR 2.0 does deliver better than native image quality in this scene. The native TAA implementation is soft and prone to shimmering with fine detail. FSR 2.0 quality mode cleans up these artifacts and is sharper overall, using the default sharpness setting of 10, though you can tune the sharpness to your liking. FSR 2.0 is also noticeably better than FSR 1.0 using the ultra quality mode. While some areas of the image are equivalent in sharpness between the two FSR variants, FSR 2.0 has less shimmering and better fine detail reconstruction. This was a major weakness for FSR 1.0 and spatial upscaling in general, which has been resolved with the temporal approach used for FSR 2.0. Of course, the big question mark is how FSR 2.0 compares to DLSS in the quality modes. In this scene, FSR 2.0 is slightly sharper and DLSS has slightly better reconstruction of fine detail. The expand your mind sign is that bit clearer with DLSS, but the fine railing detail looks quite similar, especially when playing the game. Elsewhere, you'll see a less soft image with FSR 2.0, though again, if you think the image is too sharp, you can just turn down the sharpness to be in line with what DLSS offers. The balanced modes are very similar to what we were just showing with quality. FSR 2.0 loses a bit of fine detail here compared to DLSS, but the general image is pretty similar. The performance mode is also, again, a continuation of this trend where DLSS is able to preserve a bit more fine detail in static scenes. However, the overall presentation is pretty similar. Whereas FSR 2.0 performance compared to FSR 1.0 performance is a night and day difference. FSR 1.0 looks horrible here, while FSR 2.0 is a clear and significant step up in reconstruction quality that gets much closer to what DLSS offers when upscaling 1080p to 4K. Here is another example, and I'll focus on the FSR 2.0 versus DLSS comparison. It's very difficult in this scene to discern any difference between what FSR 2.0 quality and DLSS quality offer, aside from the FSR 2.0 image being sharper with its default setting. When turning the sharpness slider all the way down to 0, the FSR 2.0 and DLSS images look effectively the same. It's really not the sharpening pass that is doing the heavy lifting with FSR 2.0, it's the underlying reconstruction algorithm, which appears remarkably similar to DLSS despite not using AI technology. Again, when comparing the performance modes of both FSR 2.0 and DLSS, it's very difficult to spot any differences. Yes, I could nitpick a few things here and there, but both technologies are extremely effective at reconstructing this scene and equivalent to one another, at least for static imagery. Do you want to see how FSR 1.0 performance mode performs? Of course you do. Here it is, and yeah, FSR 1.0 is not great at this level of upscaling. But as we all know, static scenes are only part of the story. We need to also see how FSR 2.0 and other techniques perform in motion. So let's look at that. Comparing FSR 2.0 quality to native, and overall the FSR 2.0 image looks very good and clearer than native for most aspects to the presentation. However, like with most upscaling techniques, we do lose a bit of image stability for very fine detail in motion. The railing here is softer with the native 4K image, but loses less detail in motion compared to FSR 2.0, but aside from this, the FSR image is very clear. Comparing FSR 2.0 and DLSS in their quality modes is very interesting. Most of the image follows the general trends we saw looking at static scenes in that there's not much separating the two techniques. If we look at the brickwork, the library sign, or the gun, both look basically the same. But if we look closely at the fine detail in the top part of the image, there are some differences. FSR 2.0 does a worse job of reconstructing the fine railing detail. The image is more stable and closer to native when using DLSS. However, the ropes attached to the balloon are actually more aliased in motion with the DLSS image versus FSR 2.0. I mean, both of these effects here are rather subtle. Zooming and slowing down the footage is required, but it's interesting to me that there's no clear winner and that both technologies are doing different things in how they approach difficult fine detail like this. And here's FSR 1.0 Ultra Quality thrown into the mix, which has a less stable and less detailed image compared to FSR 2.0 for the most part. Comparing the performance modes of FSR 2.0 and DLSS is a minor win for DLSS in my opinion, though both images are worse than native and do lose some fine detail in motion. It's the single pixel level details that DLSS does a better job of reconstructing. If we look at a different area, say the library sign, both FSR and DLSS look basically the same, even when upscaling from a 1080p image. I won't subject your eyes to the soup that is FSR 1.0 performance mode in this test. Who am I kidding? Of course I will, but you have to shield your eyes from the glaring artifacts here across the entire image. This is another example of FSR and DLSS in motion using the quality presets, and honestly, I found it very difficult to spot a difference here. The FSR 2.0 image is a bit sharper in my opinion, but overall they are basically equivalent in this scene. Then using the performance modes in the same scene, the DLSS image is slightly more stable for very fine detail, but I was only able to notice this when slowing down the footage. It's very hard to spot while actually playing the game. So 4K looks quite favourable for FSR 2.0 compared to DLSS in most situations. I'd give DLSS the slight edge overall for how it's able to keep a more stable image when using the performance mode for reconstructing fine detail, but FSR 2.0 is clearly a massive step up over FSR 1.0 and gets very close to Nvidia's offering. But how about lower resolutions? Let's check out 1440p image quality. In this scene, revisited now at 1440p, both DLSS and FSR 2.0 improve upon the native 1440p image, which is very soft with its TAA implementation. FSR 2.0 is the sharpest image of the three, and that's the main difference between it and DLSS using the quality mode. Of course, like at 4K, you can turn down the sharpness if you want, and FSR 2.0 basically looks like DLSS, though I tend to find the added sharpness improves the 1440p image. TAA and DLSS often look quite soft across a large number of games that I've personally played at 1440p. If we zoom into this plant, both DLSS and FSR 2.0 look very similar. I shouldn't say the same because they do reconstruct in different ways, which does lead to different image quality, but they are similar. The Your Mind sign I feel looks better with FSR in this scene, but the fine plant detail is a bit clearer with DLSS. It's a much of a muchness. Meanwhile, the FSR 1.0 ultra quality image looks pretty bad, especially for the fine grass detail. I'd strongly prefer to use FSR 2.0 here. The performance mode's pretty similar to what we saw at 4K. The DLSS image is more stable and better able to resolve fine detail. However, FSR 2.0 gets close for the majority of the image. The default sharpness setting does still make the FSR image sharper. FSR 1.0 performance looks so bad here that using this setting at 1440p should be illegal. Temporal upscaling is far better. Here's another example showing FSR 2.0 versus DLSS. Quality versus quality looks very similar. So if you're planning on using the highest quality mode at 1440p, which is what I would generally recommend you do, then either option delivers great results. Using the performance mode, generally don't recommend this for 1440p gaming, but if you are interested, DLSS is superior here at providing a stable image. Now looking at motion, both DLSS and FSR 2.0 suffer from a reduction in image stability for fine detail versus the native image, which is usually why we don't consider temporal upscaling to be capable of better than native image quality at target resolutions below 4K. With each offering here using the quality mode, DLSS is able to provide better image stability for fine details, like we saw in this same test at 4K. Focusing on the fine railing detail, DLSS is reconstructing this area better, no doubt about it. But other areas of the image? I'm not so sure DLSS is superior at all times. This other larger railing looks better in the FSR 2.0 image in my opinion, and the overall sharper FSR 2.0 image helps with areas like the brickwork and gun, though this is user adjustable and can be made to look like the DLSS image if you prefer a softer presentation. Also worth talking about is ghosting. This has been a non-issue for these upscaling technologies so far in this game, with no ghosting present in the images we've looked at previously. But here I did start to see some issues with the DLSS image. This area of the gun did show some trailing in the DLSS quality image, but not the FSR 2.0 image, perhaps highlighting that FSR 2.0 is better equipped to deal with ghosting straight away. However, I didn't really notice many differences elsewhere, so it's hardly a big deal, and it may be down to how the developers have implemented these technologies. Deathloop is currently using DLSS 2.3.0.0, which is not the latest version we've seen in other games, but it was released after Nvidia's main updates to address ghosting that we looked at in December of last year. Using the performance mode at 1440p, everything we were just talking about is still the case, just to a greater extent. Here, DLSS is clearly superior to FSR 2.0 for resolving fine detail in motion. There's quite a large advantage to Nvidia's technique. But in my opinion, the differences in overall sharpness are even more pronounced as well in favor of FSR, as well as a more noticeable ghosting on the DLSS image. The fine detail reconstruction is enough for me to preference DLSS overall here, but I don't think it's a clear-cut win, and it depends where you're looking. At this point, I think we have a fairly good idea of the strengths and weaknesses of each approach, but let's wrap up the image quality analysis with a look at 1080p. I'm going to mostly focus on FSR 2.0 versus DLSS here, and in the past, I haven't been overly impressed with how temporal upscaling works at such a low resolution, but basically everything we've been talking about in the 1440p section applies here. DLSS has better image stability for fine image details, but the overall image is softer due to FSR 2.0's more aggressive sharpening by default in comparison. I think both FSR 2.0 and DLSS look reasonable using the quality setting, and certainly far superior to FSR 1.0 Ultra quality, which really struggles at 1080p and has poor image stability and lots of aliasing. Using the performance modes, generally I believe DLSS looks better here, but this is a kind of last resort scenario, and I don't really recommend using upscaling at such a low quality mode. There simply isn't enough data to reconstruct the image properly. This is especially true in motion, where both FSR and DLSS look pretty average. DLSS does look better, a continuation of their strength at reconstructing fine detail at low render resolutions, but in all cases the native image is best here for playing at 1080p in motion. At a pinch, I would choose to use DLSS quality mode, then FSR 2.0 quality in that order, and I wouldn't bother with lower settings. So we've seen image quality, now let's look at performance. In this video I've tested two GPUs, one from Nvidia and one from AMD, to see how FSR 2.0 stacks up in terms of improving performance. But in a follow-up video I'll be including many more GPUs that I've been slowly working my way through. Didn't get everything done in time for this video, but I do want to go back and see how FSR 2.0 works on older cards. So with the Nvidia GeForce RTX 3060 Ti, which I chose not to immediately CPU bottleneck the GPU on my Ryzen 9 5950X test system, FSR 2.0 is quite effective at 4K with ray tracing enabled. FSR 2.0 quality saw frame rates jump from 41 to 61 FPS, much more playable with these settings, while the equivalent DLSS setting saw 64 FPS. This made FSR 2.0 at minimum 49% faster than native, and DLSS 56% faster. Comparing DLSS to FSR 2.0 was a small 5% advantage for DLSS, which is right on the border of what we usually class as negligible. As the quality modes get lower, the gap between FSR and DLSS shrunk. Using the performance mode saw DLSS come in just 3% faster overall, so FSR 2.0 is getting pretty close to DLSS despite not using dedicated hardware processing. Meanwhile, FSR 2.0 quality mode is somewhat faster than FSR 1.0 Ultra quality, despite delivering clearly better image quality, so that's a good win for the new FSR version. At 1440p, very similar story to what we just saw at 4K when comparing FSR 2.0 to DLSS. DLSS ended up less than 4% faster across the board. FSR was capable of a performance uplift anywhere from 32 to 56% better than native, while DLSS was sitting at a 37 to 57% increase on native. For both 4K and 1440p in this game, it makes sense to use DLSS over FSR from a performance and image quality standpoint, however the differences are quite small in the end. At 1080p, we pretty much immediately run into a CPU bottleneck from enabling either FSR 2.0 or DLSS on their highest quality settings. We can get a small performance uplift, but I don't think it's worth it for a reduction in image quality in motion. On the equivalent AMD GPU, the Radeon RX 6700 XT, obviously we can't compare to DLSS here, as AMD GPUs don't support DLSS. But what we do see are similar performance uplifts to what was the case on the 3060 Ti. At 4K, FSR 2.0 provided a 47% performance uplift over native rendering using the quality setting. We saw a 49% uplift on the GeForce GPU. Similarly, we see that FSR 2.0 quality runs slightly faster than FSR 1.0 Ultra quality for a much better image, though FSR 1.0 performance remains the fastest option available. Using FSR 2.0 performance versus FSR 1.0 performance saw a 7% drop in frame rate, which is well worth the cost for the huge improvement to visuals. In this game, there is quite a substantial performance drop for upscaling versus just running at a lower resolution for all upscaling modes, which can be due to a number of factors. At 1440p, we see similar results, a 44% improvement to frame rate using FSR 2.0 quality versus native rendering, which was a higher uplift than we saw from the 3060 Ti. However, the 3060 Ti itself is faster overall at this resolution with ray tracing enabled. Then at 1080p, we're not as CPU bottlenecked here due to a combination of AMD being weaker at ray tracing and lower DX12 driver overhead, which allows FSR 2.0 to exceed 140 FPS using the performance mode. Again, I was able to run FSR 2.0 on GPUs like the RX 574GB with no issues and still achieve performance benefits in this game, but we'll get to that more in a follow-up video. Overall, I've been impressed with this first look at FSR 2.0, but I think it's important to stress here that we are just looking at a sample of one. So It's hard to draw any major conclusions. Certainly, to say whether DLSS or FSR 2.0 is better or how close they get requires looking across more games, which hopefully will be possible soon. But at least in Deathloop, which I believe has quite a good DLSS implementation, FSR 2.0 can be competitive with Nvidia's technology. In this game, FSR 2.0 is able to produce the fabled better than native image quality at times, mostly as the native presentation uses a soft TAA that still has some shimmering issues. It can do this while providing a decent performance uplift similar to DLSS, and it seems to run just as well on Nvidia hardware as it does on AMD's own GPUs, so no special optimizations here. The benefits over FSR 1.0 are immediately clear when enabling FSR 2.0 and playing around with different resolution and quality setting combinations. FSR 1.0 was really only usable at 4K using the ultra quality mode, and at a pinch with 4K quality and 1440p ultra quality depending on the game. FSR 2.0 on the other hand has a much wider range of usable modes and resolutions without totally destroying image quality. I'd say that all modes at 4K, down to the bounced mode at 1440p and even the quality mode at 1080p are all perfectly usable in Deathloop, which opens up way more options for gamers. But even comparing the best FSR 1.0 situations to FSR 2.0, and it's clear that FSR 2.0 just does a better job. The big question on everyone's mind is whether FSR 2.0 is better than DLSS, and at this stage, I can only comment on Deathloop. I have no idea whether this is a best case scenario for FSR 2.0, a worst case scenario, or somewhere in the middle. But based on this game, I think FSR 2.0 gets very close to DLSS in overall quality and performance, far closer than FSR 1.0 got, while falling just short. In the best cases, FSR 2.0 looked as good as DLSS, or at times better due to its preference for max sharpening by default, though this is user customizable. I found it quite hard to say which was better using the quality mode, especially at 4K and 1440p, where FSR 2.0 is very impressive. It was good to see a 1440p upscaled image that wasn't soft. DLSS can often be a bit soft at resolutions below 4K, and FSR 2.0 held up better for ghosting with no visible issues compared to a few minor instances with DLSS. At times, the fine detail reconstruction was just as good as DLSS, a major strength of Nvidia's technology. However, DLSS still has an advantage when reconstructing from lower render resolutions. This is most noticeable using the performance mode, where neither DLSS nor FSR 2.0 is better than native in motion, but DLSS has a more stable image with better reconstruction of fine details. It really depends on the scene though. Sometimes the DLSS advantage was very noticeable, and at other times it was negligible. Whereas going back and using FSR 1.0 performance mode and, temporal upscaling is far superior. Even if FSR 2.0 wasn't quite as good as DLSS overall, it gets close enough in Deathloop that I'd be happy using either technology. Personally, whenever I've used DLSS, I've used the quality setting, and I wouldn't feel like I was missing much if DLSS wasn't available and only FSR 2.0 was. They're pretty close. Of course, FSR 2.0 has one other advantage up its sleeve as well, which may negate any minor quality differences depending on your opinion, and that's compatibility. FSR 2.0 works on all GPUs, or at least the vast majority. Getting very close to DLSS's AI-based upscaling without the use of AI or dedicated hardware is quite a feat in my opinion, and opens up the door for high-quality upscaling on all sorts of GPUs. It's particularly great for owners of lower-end or older hardware, which have been unable to access DLSS as these GPUs, with the exception of the RTX 3050, don't have tensor cores. We're in this kind of weird situation where Nvidia has neglected to develop a more compatible version of DLSS, and they have no intention of doing so last I asked them, so their competitor in AMD is coming in and offering an alternative for owners of Nvidia GPUs like the popular GTX 1660 and GTX 1070. If games start integrating FSR 2.0, this could extend the life of those cards and many more, including the ever popular RX 580, RX 570, and so on, which I think is great when GPU pricing is creeping up and upgrades are less affordable than ever. Based on these results, I think for developers, integrating FSR 2.0 is a no-brainer, especially if the work has already been put in to integrate DLSS. Lots of people still use GPUs that don't support DLSS, including from Nvidia. 7 of the top 10 most used GPUs in the Steam hardware survey don't support DLSS, so it makes sense to integrate FSR 2.0 to support those gamers. You'll end up supporting more customers, which can only be a good thing, though I still think it's worth integrating both FSR 2.0 and DLSS to give current-gen Nvidia owners the option. Lastly, I can't help but mention Intel here. Intel announced their widely compatible temporal upscaling solution, XeSS, well before AMD, and yet AMD has managed to announce and launch FSR 2.0 before XeSS is seen in a single game. That's a bit of a fail from Intel, as I certainly wasn't expecting to be looking at FSR 2.0 in a real-world game before XeSS, though I'm still keen to see what the blue team has later down the track. Anyway, that's it for this investigation of FSR 2.0 versus DLSS, FSR 1.0, and of course native image quality in Deathloop. I want to come back and take another look at how FSR 2.0 stacks up against DLSS, hopefully in a wider range of titles sometime in the future when we get maybe 4 or 5 games we can look at and assess, whether this was a best case scenario or a worst case scenario or whatever. We certainly don't want to draw too many conclusions here, but at least for this early preview look at FSR 2.0 in Deathloop, I have been pretty impressed with what AMD has been able to achieve with this new version. I'll also be back shortly to take a closer look at performance in a wider range of situations. I'll be going back and looking at quite a number of GPUs from different generations, things like RX 570 I've got in there. I've been testing, GTX 1650 Super, GTX 1070 I think is also in there. So testing a wide range of hardware that doesn't support DLSS to see how FSR 2.0 improves performance on those cards. And so far I'm seeing pretty good results, but again, check back on the channel soon for that video. Anyway, that's it for this one. Thanks for watching. Patreon float plane, nearly forgot about those things if you're interested in supporting the channel directly. And yeah, that's it. Thanks for watching. I'll catch you in the next one.